Hello, everyone. Welcome to this fifth episode of our Navigating the Cyberland webinar. And today we're going to talk about the Sunburst attack that happened last month. I'm your host, Abid Samhouri, and I am the lead of Axon Cyber Institute. And this monthly webinar takes place on the second Thursday of every month. I'm glad to see you all here. Just before I start, just give me a confirmation that you can hear my voice clearly and you can see the screen. Okay, great. Thank you, Walid. Thank you, Joseph. Thank you all. So, I'm sure, guys, you have heard about the news last month. It was all over the news, the cyber attack, state-sponsored, believed to be from a Russian threat actor, and the damage that happened to US government agencies, many of them, to many Fortune 500 companies in the US, as well as other public and private organizations around the world. It's expected that more than 18,000 private and public organizations have been affected by this attack. It's one of the most severe, largest, and most damaging and impactful attack that took place probably in the history of the, in the cyber history, in the history of the digital arena. So today, we're going to talk about this attack all from the beginning to the end, from all what has been known about it, the discovery, the initial discovery, to the depth, to the in-depth technical analysis. And I have even prepared for you some live analysis and live demo of this attack here. So we're gonna go together over some reverse engineering and decompiling the code and going through the methods and the classes of this malware. I'm gonna show you how you can even do your own analysis of this malware, from where you can download it, what tools you need to start even investigating this malware on your own if you want to continue. So the agenda of this presentation or this webinar is going to be like this. We're going to talk about how the initial discovery of the attack happened, what were the mistakes that the attackers fell into or did that made them get caught or get discovered, and what other companies have done, cybersecurity companies have done to unravel the mystery of this attack and to reverse engineer it and to show the public of what happened. And I have to even state that the entire puzzle has not been discovered fully. Every week and every day, new pieces of the puzzle get discovered. And then I will talk about what made this cyber attack so impactful. There are different factors that have been all together in this cyber incident that made it so huge and so impactful worldwide. So we're gonna go into, we're gonna look into these factors that contributed to the huge severity of this attack. And we're gonna talk about how the situation is evolving, what was in the past, in the beginning of this year, what is the state of this attack now, or what might be also in the future. And then we are going to look briefly into the threat actor, the suspected threat actor, and they are called APT, Advanced Persistent Threat number 29, who they are, what previous incidents they have caused, what previous attacks they have made in the past. And then we will start looking technically into the details of this attack. A major cybersecurity firm, FireEye, has done huge research in reverse engineering this malware, and they have detailed some unique activities that this malware is doing or has done in the past. So we're going to look at at those activities and how they are made intentionally so that the malware can stay stealth and undetected. And we're gonna look into some suggestions to detect each of these activities separately. And then we will look into the technical analysis through live analysis, through the code analysis that I have here, and the decompiled code of the binary. We're gonna look into the classes, the methods, the architecture of the code, and the system calls, and the hashing, and the reversing, and the encoding that's taking place inside the code itself. Prior to execution of this malware, and even after the execution, and how it establishes the command and control communication. I expect this webinar to be between 1 hour to 1 hour and a half. So I hope to make you all engaged during this time. So if we go back to the beginning of December, to the first week of December, actually December 8th, there was an announcement from FireEye. The announcement was that FireEye itself, it's a major cybersecurity firm, has been attacked, okay? And they did not reveal a lot of the nature of this attack or how it happened at that time, but all they revealed was so many of their proprietary closed source as well as open source tools have been stolen by a threat actor that is believed to be state-sponsored, that is international state actor, threat actor that have compromised or got foothold into FireEye servers, and they stolen a lot of tools. And these tools happen to be red team tools. So FireEye has large teams of penetration testers and vulnerability assessors and red teams, and who get engaged with the clients, and they have their own tools, proprietary tools, closed source tools, even though they have made some of these tools publicly available. And the tools perform things like reconnaissance, scanning, network mapping, as well as they do some exploitation, post-exploitation. So you can imagine they have like scripts and tools similar to, let's say, Nmap, similar to Metasploit, similar to Meterpreter, similar to, I don't know, something like Burp Suite, and so on. So these tools got stolen. And FireEye started working with FBI at that time and Microsoft for investigating, for investigation of this incident, and to reveal what happened exactly. And the initial announcement was made by the CEO of FireEye himself at that time. Then they have issued a technical analysis or a technical release of this attack and what exactly have been stolen, the tools that have been stolen. And they have released countermeasures. And that is the good thing about FireEye. They immediately released some countermeasures. So they have developed some indicators of compromise, some IOCs, which are publicly available in GitHub, and you can download them and you can check them. And the URL is available here on the screen. You can download them. They have IOCs for Snort, IOCs for Yara, for ClamAV, and so on. So you can detect FireEye tools if they are used by threat actor, by some adversary or some attacker. So December 8th, simple discovery of a FireEye breach. Nobody knew at that time how it happened, why it happened, who did it exactly. Then FireEye started investigating their own attack. They started investigating the breach itself, and this led them to the discovery that the actual incident was against SolarWinds. So they discovered that what actually was compromised on their network was a server that has SolarWinds product, and I'm gonna explain what that product is. It's called Orion and what it does in a while. So they discovered that the version of SolarWinds product they had at that time is Trojanized. So they have downloaded a legitimate SolarWinds update or a patch and installed it, and that was Trojanized, and that made all the infection and infiltration by the actor. So the CTO came up and he announced even that the actual incident, the actual breach of FireEye, the initial breach of FireEye was actually a huge mistake that the attacker made in the beginning, because they made themselves now visible. Had the attackers not stolen FireEye tools, probably nobody would know until this moment that SolarWinds applications and SolarWinds products have been infected and Trojanized. So the breach of FireEye has led to the investigation to uncover the breach of SolarWinds, and this is the actual attack. On that same day, the news came up that so many federal agencies have been also hacked, and the communications and email communication at so many of these agencies and other organizations have been eavesdropped upon and have been extracted by a malicious threat actor. And this became a global discovery and a shocking news worldwide. So FireEye directly reverse engineer exactly what happened, and initially they called the threat actor UNC 2452. And when FireEye calls a threat actor UNC, that means it is unidentified, unrecognized. So they did not want to actually attribute it to a certain threat actor, to a well-known threat actor. However, other sources like Symantec and Microsoft and some other sources attributed to a threat actor known as APT29, or they have a name called Cozy Bear, and we will talk about them in a while. So what happened was, this attack initially took place against SolarWinds network, against SolarWinds product, in particular against Orion product. And Orion product is a very famous and very popular and very powerful product for network management, and it's widely used. Probably SolarWinds is the de facto company of network management, and Orion is used by thousands, if not tens of thousands or hundreds of thousands of organizations globally. So the attackers initially infected SolarWinds network, and they managed to implant their own backdoor inside a single version of the Orion product. And once it was deployed by the customers, they managed to get into all of these customers. So FireEye now, when they reverse engineer this malware or this Trojanized update, they called the backdoor inside the update or inside the DLL or inside the executable file, they called it Sunburst. So the malware itself has been called Sunburst, that is deployed now in more than 18,000 organizations. And the threat actor, we have APT29. Immediately, FireEye compiled a list of countermeasures, very important countermeasures, and we will look into some of these countermeasures while I'm going through the presentation. But just to show you briefly, I'm gonna share here my Okay, it looks like I cannot share Firefox at the moment because I'm sharing the VMware here. So let me continue. The URL is right here. So why this incident is so impactful? What are the factors that have amplified the severity of this attack? The first factor is the attacker did not compromise directly the target organization. They did not attack directly federal agencies or US federal agency. They did not attack FireEye directly. They did not attack, for example, Cisco directly. They did not attack any organization, affected, compromised organizations directly. What they did was an attack that we call supply chain attack, which is to compromise a product developed by a third-party vendor, and then once this product gets deployed into so many organizations, the attacker now has access to those organizations. And that is, in a simple term, what supply chain attack is. And supply chain attack is very dangerous because of the widespread impact. Unlike, for example, like the same threat actor that has done Sunburst, has done previous attacks in the past against US federal agencies, against, for example, the Democratic National Center, DNC. But the attack was limited because it only attacked a single organization at that time. However, with this one, because they managed to do a supply chain attack, they get a much wider foothold into so many organizations because they made to infiltrate a single product used by all of these organizations. So this is like, for example, sometimes ago we heard about the TeamViewer hack. The TeamViewer hack, if an attacker attacked TeamViewer servers, that means they can listen on all and intercept all communications taking place through TeamViewer. Or let's say if an attacker, for example, hacked into a VMware and then they managed to Trojanize a version of VMware, then everybody who uses that Trojanized version of VMware is compromised along the line. So now factor number one is they made supply chain attack. They attack a product used by many instead of attacking single organizations directly. The second factor was Orion product. The SolarWinds Orion product is a network management system. And what does this mean? A network management system is something that automates a lot of IT admin tasks. And because of that, it needs to access the local machines in the network. It needs to access devices in the networks. It needs to access servers in the networks. It most likely has a lot of admin passwords and admin credentials and read-write privileges into most of the systems in the organizations. And this is factor number two that made this attack so impactful is now the hacker not only compromising a single server that has SolarWinds, but because SolarWinds has read-write access to pretty much everything in the network, the attacker now has access to everything else in the network as well. So they find themselves like they have the keys to the heaven, you can say. They can access local machines, they can access managers' machines, they can access employees' machines, they can access the firewall, the IDS, they can even access security devices, they can even access Active Directory and servers, websites, databases, and so on, because the network management system, the Orion product, SolarWinds Orion product, has access to all of these devices and systems. Not only that, Not only that, I'm sure some of you who have worked either with SolarWinds or with any similar network management system, sometimes you have to whitelist the folders and files of this tool on the antivirus or your EDR in order to function properly. How many times we have done something similar to whitelist a legitimate tool so that a legitimate security tool so that another security tool will not detect it. So what happens when that security tools is now compromised or management tool is compromised? What happened then? No antivirus, no EDR, no other scanning or forensic tools can detect what malicious activity this product is doing. So this is second factor that contributed to the impact of the Sunburst attack, okay? So in summary, we have a supply chain attack that made everything easier. And then the second thing, it's a network management system that controls pretty much everything in the network. So what exactly happened? Until now, the full picture has not yet been revealed or uncovered. But what the attacker did was to compromise the software development lifecycle of SolarWinds, something we call the build process. So they managed to intercept the development process at SolarWinds, and they managed to intercept how updates and patches are being generated, and they managed to plant their own backdoor during the build process, so that when the final product or the final update or patch is published on SolarWinds channel or SolarWinds website, the Trojanized version is published. We have to also bear in mind here that the Trojanized update was digitally signed by a valid SolarWinds certificate with a valid certificate. So that's why you could not find any invalid signature in the update itself. And some people in the beginning thought that the private key, the certificate itself of SolarWinds was compromised. However, this is not the case because the attacker did not publish the Trojanized update on their own website, but rather it was published on SolarWinds website. So customers were downloading the update from a legitimate website, not from a phishing, not from a hacker's website led to by a phishing email, for example. So they managed to download it from a legitimate website, and this is what made the belief that the actual attack was infiltration and exploitation of the build process. And in January, just last week, or actually a few days ago, it's been revealed that there was another malware that is now called Sunspot. Sunspot. It has been discovered just 3 or 4 days ago. Sunspot is the malware, the initial malware that compromised the software development's lifecycle at SolarWinds, and then Sunspot was injecting Sunburst into the updates of Orion product, and then Sunburst gets deployed into the customer's network or the target organization's network. Now, what is still missing until now is how Sunspot was actually injected or planted into the SolarWinds server in the beginning. This is still a mystery, and I believe in the upcoming weeks we might have answers or more details about how the initial infiltration took place. So, just to summarize here, it's a hijacking of the software development lifecycle with a certain malware called Sunspot, and then Sunspot was injecting Sunburst inside the updates of SolarWinds. The updates are digitally signed, they get published, customers downloaded the updates, and then the attack took place. It is believed that the actual attack goes back to the spring of 2020, around April. The actual attack around April 2020. Okay. However, in 2019, the attacker compromised SolarWinds server. So in 2019, SolarWinds was compromised, and then injection of Sunburst took place in 2019. However, in 2020, spring 2020, the Trojanized updates were published and downloaded, and then all the way until December that the actual attack was discovered. And in January 2021, the Sunspot was now revealed and reversed and discovered. And whatever, God knows what's going to be in the future, but I'm sure we're going to see more news and more analysis and more discovery of this attack. Okay. Who is APT29? APT29 is a Russian hacker group. Okay, they have been active for a long time, probably since 2008. They have other names called the Cozy Car, the Dukes, Cozy Duke, Office Monkeys as well. Okay, and it is believed that it is this Russian organization or Russian group is linked to the Russian government, the Foreign Intelligence Service, SVR. So it's not a private or non-governmental actor, but rather it's a state-sponsored actor. And in the past, they have made some attacks, and notably in 2015, they attacked the Pentagon through some spear phishing cyber attack campaign, compromising some emails, some email communication. And then in 2016, they managed to attack the Democratic National Committee, the DNC, and they managed to steal password and sensitive information. And they have been present on DNC servers for quite a year, for almost a year. And also there has been an accusation in early 2020 or mid 2020 of stealing some proprietary information on COVID vaccinations. However, this is not confirmed. It's simply accusation from some US federal agencies. And now we have in 2020, also at the end of 2020, we have the supply chain attack against SolarWinds. Okay, you can Google APT29 and get more information about this threat actor and what they do. There is also APT28. It's a very interesting group. You can also check them. They have made some cyber incidents, international cyber incidents, and sometimes people confuse APT28 with APT29. But they are different groups, even though they have similar tactics sometimes. So, FireEye has identified 5 distinguished post-compromise activities that Sunburst does or performs once it is installed and up and running in a target organization. Now, I'm gonna go into the details of how the malware actually runs, and under what conditions and what checks it does before it is running. So I'm gonna leave this later. But now I'm gonna talk about once Sunburst is actually running, and once it has got command and control communication with the server, what are its unique characteristics and features that the developers have made it have developed those features inside Sunburst so that it stays undetected. Number one, the Sunburst malware drops or installs or injects other malwares later on, and these malwares known as Teardrop and Beacon. So you have got Sunburst, it establishes communication, and then it transfers the communication to another malware called Teardrop, and Teardrop transfer the malware to Beacon. And I will talk about the details of these two in a while. The second one, the second activity is the host names that are used for C2 servers. Usually they match with the host names of the target organizations, so that communications or any types of packet analysis might not raise any suspicion in the minds of the network administrator. And the C2 servers, they have IP addresses located within the victim country. This is the third unique behavior, is C2 activity happens within the local country. So it doesn't talk to servers in Russia or server in China or the US, for example, but rather it communicates with VCs inside the same country. And the malware utilizes different credentials when it attempts to access different machines. So it does not use the same credentials to access all the machines, but different credentials. And then finally, it has a very clean way of removing its tracks by removing any tool or any file that it installs and restores the state of the machine after it has utilized its own tool. So we will look into each one of these in a more detail now with how to detect each one of them. So Sunburst establishes a C2 connection with the server, and that server they have a fixed domain name. We will look into them in a while. And then Sunburst downloads a payload that FireEye has called Teardrop. Okay, it downloads Teardrop, another payload, it gets injected into memory. Nothing is written on the hard disk, unlike Sunburst. And I believe the reason why this is the case is because even if the administrator shuts down Orion service, Teardrop is still active in memory. So it's independent of the SolarWinds Orion service. Unlike Sunburst, Sunburst runs within the Orion product, within the Orion service. However, Teardrop is separate, so it gets injected into memory, and Teardrop is developed by the same threat actor. So it's a proprietary payload of APT29, and then Teardrop now has another purpose, which is to inject another payload, a third one called Beacon. And Beacon is a payload that comes with a very popular exploitation framework called Cobalt Strike. Now, if you're not familiar with Cobalt Strike, think of Metasploit. Cobalt Strike is exactly like Metasploit. However, Cobalt Strike is commercial and has some advanced features and more like a graphical interface and more interactive features and more automation. And Beacon is like Meterpreter. So Meterpreter is a payload that comes with Metasploit, while Beacon is a payload that comes with Cobalt Strike. And APT29 is well known is well known in using Cobalt Strike in their C2 communication, and in this particular case, they also drop Beacon payload in memory to establish further C2 communication. Now, it is this Beacon that performs lateral movement, remote access, pivoting, collection of passwords, and so on. Sunburst does not perform lateral movement. Sunburst is only for management, for initial foothold, for getting access into the system, profiling the system, and then jumping, dropping Teardrop, and then teardrop to beacon, and then beacon takes over for everything that is dirty post-exploitation. Now, FireEye has developed two Yara rules, okay, to detect beacon activity and to detect teardrop activity, okay, available on their own GitHub channel, and the link is provided in this channel. So if you use any product that can understand and incorporate Yara rules, you should do that as soon as possible. The next unique activity that Sunburst does, or this malware does, is the host names of the attacker has a portion of the host name of the attacker include the host name of a legitimate of the target itself. So if the target, for example, I'm going to assume my company, Axon Technologies, then the server might have a portion of Axon Technologies. So Axon Technologies might appear as a host name or a subdomain under the domain of the C2 server. So of course it's not going to be the top level, sorry, the actual domain, but a subdomain under it. So when they profile your system and they know that your system, for example, has Axon Technologies, they try to create a host name of their under their domain with Axon Technologies so that the communication appears less suspicious. However, you can do that simply by querying internet-wide scan data. If you Google internet-wide scan data, you can find different repositories online that has one job and one job only, which is to scan the entire internet. And one of these repositories is Shodan. You might be familiar with Shodan. There are others as well. And internet-wide scan data repositories, sometimes they might query a certain IP address and they might get their SSL certificates, and SSL certificates might reveal host names. So if you want to check, or if you want to detect this particular activity of Sunburst, you might search for your organization host names inside the internet-wide scan data and see if your organization host name is associated with any IP address that does not belong to you. This is one way to discover this particular activity. The third activity, or post-compromise activity, is the attackers uses IP addresses in the same country that the target is located in. So the final C2 communication does not appear to be like with a server in Russia or a server in Germany or in different continent, but rather in your own country. Now, the way to detect this, the way to discover this is you go through doing an audit of your logs, of your access logs, particularly your access logs, remote access logs. And if you have established in the beginning a baseline of where your users usually log in from, okay, not necessarily every single IP, but at least if they are in the same country, at least you can check the autonomous system numbers they are using, okay? So which ASN they are logging in from, and then see if there are accesses, if there are access logs from different ASN, especially if you see like a bunch of continuous or repetitive accesses from a strange ASN, even though it's in your country, but it's an ASN that has never been used, and you're not aware that one of your users is actually located in that autonomous system. So by checking your logs for ASNs, unique ASNs, and the frequency of logs from that ASN, you might discover if you are compromised or not. Number four of these unique post-compromise activities is the remote access that the attacker establishes inside a compromised platform is done using certain credentials that have been uncovered, okay, through the initial cracking and the initial profiling of the system. However, when the attacker would like to laterally move inside your network, they will not access other systems using the same credentials again. So they will try to compromise a different account, a different credentials, and access other systems using other credentials. And they are doing this to minimize logs, okay? But at the same time, you can detect this by seeing if there are like single systems, if a single system is accessing multiple systems with multiple accounts at the same time or within a short period of time, this might be an indicator of compromise. So if you have a single system accessing system A with account A, accessing system B with a second account, accessing system C with a third account, and instead of using the same account to access all systems, this might be a way to discover this particular behavior or this particular activity. The final one is the attacker is good at deleting their tracks, at covering their tracks. So if they replace a certain legitimate file with a malicious file, okay, to do certain work or a certain task, once they finish that task, they delete the malicious file and then they create the legitimate file again so that it seems nothing has happened. So whenever they put their own tools, once they perform the task at hand, they go ahead and delete those tools. And once they replace any legitimate tool or any legitimate task, like if it is on a task scheduler, then once they finish, they return everything to the initial state. And one way to look for this suspicious behavior is if you try to gather all your all your file logs, file behavior logs, okay, and you check for certain patterns. You aggregate those logs and you check for patterns of delete, create, execute, delete, create immediately. So this can be an indicator of the compromise. So the first delete is delete the legitimate file, create the malicious file, execute the malicious file, then delete the malicious file and create the legitimate file. So delete, create, execute, delete, create. If you see this chain in a sequence, this can be an indicator that a malicious activity is taking place. Okay, now I'm going to start with the technical analysis, okay, of this malware and show you certain, I'm gonna like go into the classes and methods and the coding of it and show you some other checks and other behaviors inside the code. But before I move on to this section, if you have any question about all the materials I have covered so far, please go ahead and type it on the screen, type it on the chat, and I will be happy to answer you. If no question, then I will move forward with the technical analysis. Fahad is asking question. Thank you, Fahad. How can they do the IP impersonation? They are not doing IP impersonation. They are not spoofing their IP to be an IP of somebody else. However, what they are doing, they are buying virtual private servers inside different continents and different countries, so that the IP addresses of these virtual private servers are used for C2 communications. Okay, so they are buying, like they have an array of virtual private servers in various countries. Okay, and then they utilize those IP addresses for C2 communication. Walid is asking the question, did you mention that they create a host with a name same as the organization name? Here is something. They cannot create exactly the same domain or the same host name as a fully qualified domain name. However, what they can do, they can put in their domain name, they can put inside the host name or the subdomain, they can include the name of your organization or your host name inside the organization. Okay, so if, for example, I'm gonna type here, if the malicious domain is, let's say, doccloud.com, this is the malicious domain. Okay, and they have compromised, let's say, Axon Technologies.com. What they might do something like they create a subdomain, Axon Technologies. Axon Technologies, for example, subdomain .doccloud.com, something like this. Okay, so you might see your own organization host name, okay, or host names within your organization as part of the host name or this under the subdomain of the malicious domain. Okay. Okay. Walid is asking another question about the server being located in the same country, for example, Lebanon. Remember, if they want to target an organization inside Lebanon, and I'm not sure if they are doing that, okay, they need to buy certain servers from cloud providers inside Lebanon, okay? You have got some cloud providers inside Lebanon, okay? There are well-known companies in Lebanon that they provide you with your own virtual private server or your own platform, okay? And they have like a hosting, they are a hosting organization, and then they use this hosted platform at the C2 server, or at least as a pivot to talk to another C2 server somewhere else. But from the target organization, it appears they are talking to a server in Lebanon. Now, I'm not sure if they have gone this far for each country in the world, but at least the major countries, like let's say US, UK, Germany, France, blah, 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 they have bought VPSs with IP addresses in those companies, in those countries. Okay, so let us move on to the technical analysis of this Sunburst malware. And if you're interested in reversing this malware, if you want to explore this and decompile this Sunburst malware, and even the next one that is now being released, the Sunspot, okay, we all know you need a certain debugger, okay? And one particular well-known debugger for .NET tools or for .NET executable files is the DN spy, okay? You can download it from their GitHub page. It's a debugger, it's an assembly editor, and it is a hex editor. And I'm gonna share my VMware over here, my VM, okay, to show you, okay? I hope you can see this stuff over here, okay? So, let me just verify, okay. So, you can download it and then you can open it, and this is basically the main window of it, okay? Now I have dumped already the DLL here, but once you open it, it appears over here. I'm gonna open another instance, for example, just to show you. Basically, it's a decompiler, okay? And you can see the actual code of a .NET binary, and you can modify even the code, and you can do some static analysis, very powerful for static analysis, okay? So you have this tool. There are other tools as well, but this is one of the best, as at least for a starter, okay? Next, you need to download the sample, okay? You need to download the sample. And we can download the sample from an online service, an online website called any.run. And any.run is a malware analysis or a malware sandbox service on the cloud, okay? So you can go there, you can dump your own executable, try to test it, assess it, blah, 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 and you can even see what other malware or suspicious files that other people have uploaded, and you can even download them yourself. So basically, I have gone to any.run. So you can go to any.run. Any.run. Register with an account, okay? And then from FireEye GitHub, if you go to FireEye GitHub, the main FireEye GitHub, that they have the project that they talk about, Sunburst, you will see certain hashes of the compromised DLL files, okay? And all you have to do is you take one of those hashes and you dump it inside any.run, and from there you can download the actual compromised or the actual Trojanized file itself. And I have already done so over here. So I have downloaded this package over here, okay, with this hash. It's a binary. You download it as zip, you unzip it, and it includes the binary file. This is the DLL, the compromised DLL of Orion product, okay? This is basically what we have over here. And once you download it, you can simply dump it inside the DN spy, okay? Once we have dumped it over here, you can see the SolarWinds.Orion.core.business layer. This is the business layer DLL that comes with the entire update package. This is not the only file in the update. This is a component of the entire update file. And this is where they injected their own malware inside this DLL. And if we expand it, okay, we expand further the DLL, okay, we can find here the business layer, which matches the DLL itself, and we can even expand this further. And what we find here are the classes. These are the classes, okay, and there are also the variables. Some of them are variables, and the classes here are all legitimate. These are all legitimate classes inside a legitimate DLL file, okay? However, there is only one class over here that is the actual Trojan itself. And the attacker has used naming convention not in obfuscated way. There is nothing obfuscated here on a large scale inside the code. They have used naming convention to appear as normal, to blend well with the entire architecture, software architecture over here. So there is one particular class, particularly the Orion Improvement Business Layer. This is the addition of the attacker, Orion Improvement Business Layer. Once you see this, this was never built by SolarWinds team. It was what the Sunspot has injected. You expand this, okay? Now, by the way, all of this information I'm talking about here has been well detailed and well explained by FireEye and some other security firms like Symantec and others. So you can even read their guides, you can even read their research, and you can take what they have talked about and investigate in this malware. So this is the addition of the threat actor. Now inside this, this is all what the backdoor does, okay? The malicious activities, okay? Now these are methods over here that the class invokes, and you can see there is one called initialize. Initialize is the initializer of this class, okay? And it is the first method that is being called of the class to actually start the class, okay? Every class has a method that is the initializer of the class itself. Now, somehow this needs to be called from outside the class, the initialize. Who calls it? If we analyze it over here, we find out that it is being called by another class called inventory manager with the method refresh internal. Now, inventory manager is a legitimate class. It has been developed by SolarWinds, and refresh internal also has been developed by SolarWinds. This particular class and this particular method runs as a task in the background, as a job in the background, okay? And it does some refreshing of the of certain processes or certain tasks of Orion product. Because it runs continuously and there is like somehow a refresh within it, the hackers made the call to his Orion Improvement Business Layer, as you can see here, from the refresh internal. So refresh internal calls the initialization of this malware. Now, what happens when the initialize function is called? Okay, what happens? If you check, this is the initialize function. We have got if here, okay, and then another if here, and then another if, and then another if, okay? If this is successful, and this is successful, and this is successful, and this is successful, and also this is successful, then execute this. And this means the actual now backdoor doing its nifty stuff, especially with the update call, okay? The update call, that means the backdoor is now successfully running. Now, if all of these if fails, or any of them, if any of these checks fail, then the backdoor terminates, okay? It does not continue. And this is one way to make it stealthy. So what are these conditions? I'm gonna go through them one by one. The first one checks if the process name matches a certain process name. If they expect a certain process name, and that process name that process name is here, SolarWinds business layer host. That means the process must run under this name. Okay, it must not, if it is running under any other name, it terminates. The backdoor will not run. And this is the default name of SolarWinds, SolarWinds Orion process of this DLL. Okay, once it is running, it's running at this name. Any other name, it terminates. Now, if you go to the code itself, if you go to the code, we will see there is a strange number over here, and we're gonna encounter a lot of these numbers. These numbers turned out to be hashes, okay? And every static string somehow is either hashed, okay, or encoded in a certain way, okay? And part of your malware analysis is to actually decrypt, is to actually decode and try to reverse those hashes. And I'm going to tell you what those hashes are in a while. Okay. FireEye has done a great job in reversing those hashes. Okay, they have done a great job in reversing those hashes, and they made a list of all available hashes. Okay, I'm not gonna go through them, but on their GitHub, you can see each of these hashes and what they actually mean. So this one, as I said, it is the process name, the static process name of the Sunburst. Once this is successful, okay, it checks the last write time. When was this DLL written in the hard disk? Okay, if it is written more than 12 to 14 days, then continue execution. If not, terminate. Why this is the case? Because let's say your company has a proper way of patch management. You have downloaded the update, the SolarWinds update in your environment. However, before putting it in production, you are testing it in a testing isolated environment. The question is, how long you're gonna test it for? You have deployed it today. You might check it for 1 day, 2, 3, 4 days, okay? And there is nothing suspicious. Everything looks normal, okay? No one would actually put an update in testing for more than a week, okay? Even a week seems a long time. So they made it here to wait for 12 days, 12 to 14 days, okay? And the actual number is random. So it could be between 12 to 14. So some customers, they might, the actual number can be 12, and another customer can be 13, 14, 13.5, and so on. So you get a number between 12 and 14, and then you compare the date of writing to this number and see if it is older than that number. Once it is old enough, okay, at least 12 to 14 days old, has been written in memory, then it goes and it creates something we call named pipe, okay? And a named pipe is a pipe. We all know what a pipe is. It is a stream for inter-process communication. It has two ends, one for writing, one for reading, and has some other purposes. But it creates a pipe over here, and it gives it a name, and the name is a certain ID here, okay, and it is a static, okay, it is a static ID. It gives it to this pipe, and the reason why this is done is because if you try to call this function another time, and then it attempts to create a named pipe with the same ID, it fails. Okay, it fails, And if it fails, it does not continue. This prevents the backdoor from running twice on the same machine. Okay, so it makes sure it is not called another time. After that, it tries to read a configuration file associated with the DLL. It comes with a package, and it tries to read a certain variable in it called the status, and it tries to make sure the status is not truncate, okay? And truncate is equivalent to 3. And if it is not 3, if it is not truncate, continue. If it is truncate, terminate. And the hacker, through the C2 channel, can change the status to truncate anytime if he does not want to control the machine anymore, or he has realized that the target is not worthy for him. So he simply truncate, and then the process will not do anything and will terminate. After that, it retrieves the domain name of the target machine that it is inside, okay? It receives this domain 4 over here, the domain name. So if there is no domain name, if the machine is not domain joined, it terminates. If it is domain joined, it has this function over here to check if the domain name is invalid. And by invalid means it checks for a certain block listed names, okay? And if we go to this method, okay, we see a comparison of a pattern hashes here. We see a list of hashes. And these hashes, according to FireEye GitHub repository, they match to certain domain names. Some of them include like test domain names, or they might include SolarWinds. So anything that contains SolarWinds or test or certain domain names that they have, the attacker recognizes as unworthy of him investigating, then it terminates, okay? Unless it is like a valid, unique, okay, not blacklisted or blacklisted. Once it is domain joined and the domain name is valid, it goes on and creates something we call user ID. And the user ID is very important. The user ID is a mix of the global unique identifier from the registry of the process, plus the domain name of the actual target, okay? Plus some other things, the MAC address also of the machine. And this user ID is transferred to the C2 server at a later stage. And it is from there, from this user ID, the attacker would know what target he is dealing with, okay? And then once the user ID is valid, there is a MAC address, there is domain name, okay, and there is a global unique identifier. It moves now in, and then it calls, after the delay, it calls this update, okay? Now the update does other checks, okay, other checks, and then it does the C2 establishment. I want to mention two things here. Number one, the hashes over here, okay, they are in the format of something we call FNV1, okay, FNV1. I'm gonna write it here in Google, FNV01. So if you want to read more about this hash function, it's a very, very simple hash function, Fowler null vo, okay, FNV, okay, it's over here. And they are using it in their code. So, and let me find the FireEye GitHub URL. Just give me a second. I have it over here. So, under Sunburst countermeasures of FireEye, okay, we have indicator release. Okay, and then we have hashes CSV. Okay, sorry, this is, sorry, it's here. FNV 1A XOR hashes. This file contains all the reversed hashes so far, okay, by FireEye. And anytime you encounter one of these hashes, okay, because you will encounter many later on, you can copy it without the UL at the end. The UL indicate unsigned long integer. So you omit it, and then you can search for it over here. And for example, this one translates to this name. And if you go to the, for example, checking the domain name under here and the pattern hashes, the ones we found here, you can pick, for example, let's pick one here. And let us search for it in this list. Okay, cork.lab. So cork.lab is blacklisted. That means if the domain returned by the target is cork.lab, the malware terminates immediately. Okay, so it must not include any of these lists. So you can reverse and check each one of these on your own. The other thing you need to know is while analyzing the code, you will bump across unzip function, okay, a lot that takes base 64 encoded. Now this is not only base 64 encoded strings, but they are compressed using the zip method, and then encoded using base 64. So every time you encounter one of them, you can go to a website, something like CyberChef, and in CyberChef, you can add any function you want. And in here, we're gonna add decoding base 64 and also inflate, which is the compression algorithm, the deflate compression algorithm. This will help us during our analysis. So we have reached the update. Okay, but let me show you a demo first of how to actually decode one of these base 64 in CyberChef. So you will add from base 64, because this is base 64, we want to decode it. However, it does not decode nicely because it is still compressed, okay? It is still compressed using deflate, which is the default compression algorithm for the web. And to decompress it, we will use the raw inflate widget over here. So this particular base 64 indicates a certain IP address. So it has a block list of certain IP addresses used somewhere, okay? Those IP addresses can be, for example, a blacklist. Once they are found, it terminates. The same with the hashes, okay? So let us move on to the update, okay? The update now does two major things before establishing, or let's say it does three major things before establishing the HTTP C2 communication, okay? The first thing it does is it acquires all processes that are running, okay? It gets a list of all processes that are running. And what it does with the list, it compares them with a block list of processes. So it checks if there is any block listed process, any block list process is in memory, is running right now. And if it finds any of them, it terminates, okay? Now, what are these processes? These processes are related to some antiviruses, some EDR, some forensics tools, okay? Some process monitor. Once it is as if the attacker is aware if one of these processes is running, that means the machine is being handled by a security analyst or a forensic analyst or some security professionals, okay? Because used by a security professional, or the computer is being monitored by some powerful security tool. So we have a function here called track processes, okay? We will jump to it now. And inside track processes, we have search assemblies, okay? And search assemblies, it compares with assembly timestamps. So it goes through this list, okay? And let's take one here and search for it. Search for it here. Okay, autoruns. So if there is a process called autoruns, it terminates. Okay, another process, let's take this process. D4.dot. D4.dot is a very good tool for decompiling and for malware analysis, okay? You can use it in conjunction with DNSpy, okay? It actually can modify the code so it makes it simpler for analysis, okay? So the third one, I'm gonna take, this is the last one I'm gonna take from the list, okay? Just for curiosity, and see, Fiddler, okay? Fiddler is a tool similar to Burp Suite and Zap Proxy, okay? Albeit it's simpler than Zap Proxy, but it's for intercepting and analyzing HTTP traffic. So if Fiddler is running, Sunburst terminates directly, and so on. So the second thing it does after checking the list of processes is it checks the list of services as well, okay? It checks the list of services. And just like it did with the processes, if one of the blocklisted services is running, at this time, it does not terminate. However, it tries to disable it in the registry, okay? To disable it in the registry, okay? You can also go through it and find the timestamps, okay, of these hashes. Okay, I'm not gonna waste a lot of time searching for the services hashes, but what I'm gonna tell you now, after it checks the running processes and running servers, okay, it generates now host names. It generates host names, and the host name is generated using a certain complicated formula. It actually hashes the user ID and the MAC and the domain name, okay, and then append it to certain subdomains and certain domain name, and it tries to resolve this domain name. Let's go back to the slide here to show you exactly what kind of a generated host name there is. Okay, so it generates a host name using the user ID and the encoding of domain name and some random number, and then it appended to one of these subdomains and domain names, okay? AppSync, okay, API EU West or US West or US East or US East 2. And then the final portion is static, avsvmcloud.com. This is the main domain used by the attacker. And once this main domain has been taken control of by Microsoft, Sunburst no longer can function, okay? No, unless they manage to modify the hard-coded Trojan to resolve a different domain name, okay? So it generates a domain name, a fully qualified domain name, and then it attempts to resolve it. It attempts to resolve it. Now, once it attempts to resolve it, it gets an interesting thing. If it gets an IP address that is a private range, like 192.168.00/16 in that range, or like 10.0.0.0/8, or any of these private addresses, terminates directly. One funny thing, one ironic thing is if the IP address falls within the range of Microsoft IP ranges, it also terminates immediately. Okay, so it has to be public IP, and public IP not used by Microsoft. Why Microsoft? I don't know why Microsoft, why Cisco is not here, other like vendors are not here, only Microsoft, okay? Once this is the case, once it was able to resolve it, okay, it receives from that server now, from the resolved server, a CNAME record, okay, and the CNAME record includes another domain. And some of these domains could be freescanonline.com, deftsecurity.com, the doccloud.com, okay? These are also owned by the same threat actor, okay? So initially, it talks to the SVCM or SVSM, I believe, okay? And then it gets one of these, okay? And then it establishes HTTP connection with one of these. If we go back to the GitHub, and if you go to the indicator release, by the way, just a side note, if you go here to the hashes SCV, the hashes here are the hashes of the compromised DLL files. So the binary that I am working on decompiling is the DLL file with this hash, okay? And this is its version. So each version of this DLL, the SolarWinds Orion Core business layer, okay, is considered Trojanized, and each one of them has its own hash over here, which you can search, as I told you, at any.run, okay, and download the sample of it. Now, if you go to the other file, the NBI file, this is where the domain name gets resolved. So we have names like these, okay? This is the name that I told you about, something something encoded with the user ID plus the domain name of the target appended to this subdomain and the fully qualified domain name. And then through a CNAME, it gets resolved to one of these. FreeScan, deftsecurity, the doccloud, and so on. And then it establishes a connection, okay? It establishes a connection to one, to that server, okay? So let me show you here where connection establishment is done. At the beginning of the update method, we have something we call HTTP helper, okay? The HTTP helper belongs to another class, the HTTP class, and the HTTP class is responsible for all the C2 communication. The crypto helper is responsible for the base 64 and the zip encoding and the compression, and the decoding and the base 64 decoding as well. Now, if the processes are fine and the services are fine, okay, then it tries, as I said, it generates a domain name, it tries to resolve it and gets a CNAME, and inside the CNAME it gets the second server now, the one responsible for the C2 communication. And then over here, if the CNAME is not null or empty, then it forks now a thread. It creates a thread, okay, and make sure it does some check. And then if everything is fine, it runs this thread with initializing the HTTP helper, okay? So the HTTP helper, this is another class inside our main class, so it's a nested class, a class within a class. HTTP helper is right here. It has so many methods, okay? The initialize is the first one that is being called, okay? Now, the HTTP helper is responsible now for creating the GET request and POST request to the server, and then for receiving the responses, and then extracting the command, okay? Extracting the command. Let me go back to the slides to show you something. So it establishes GET and POST request, and inside the GET and POST request, we've got a payload, JSON payload, okay? In the response contains jobs, okay? And jobs are the commands that actually control the target, okay? And then the client now, the Sunburst, through the HTTP helper, extract the command, okay, through some decoding and regex and so on. And then it executes the command. It sees what this command is. So I'm going to show you the commands now quickly, and then conclude this webinar, this session. So once it receives a command, after it extracted, it goes to something we call execute engine. Execute engine is responsible for executing the command, okay? Some of the commands are obvious over here, like set time is a command, okay? And also we have run task is a command, okay? So it runs the command. Kill task is another command, okay? And all commands are being managed by a class we call job. So if you go to the job class, we should find implementation. This is job. We find the implementation of all commands. So we have collect system description. So this collects various information about the target, like the host name, the IP addresses. It profiles the target. You can delete file, so it deletes certain file. Delete the registry value, so it goes to the registry and deletes certain value as you specify. File exists. This it checks if a certain file exists or not. And you have got get file hash. So if the attacker would like to get the hash of a certain file, it runs this command. Get file system entries. This is like ls, okay, or dir in DOS or Windows. So get file system entries. So it lists available files and directories inside the specific path. Get process by description. It lists all available processes. Get registry subkey and value names. So if you give it like a certain key, if you give it a certain registry key, it gives you all the subkeys and all the values inside that key. Kill task if you want to terminate a certain process. Read registry value if you want to read from registry. Run task to execute a task. set registry value if you want to write to the registry, set time. The time is used for delays. You will see that Sunburst implements a lot of delays during its operation. And delay is simply just not to make things suspicious by having too many activities at the same time. So it can sleep between operations and between tasks. Upload system description. It crafts an HTTP request and then it sends system description to the remote server. Write a file. You can create a new file and then write a certain payload inside the file. Now, these are the commands. In order for Sunburst to continue through the teardrop and the beacon payload, what the attacker would do generally is would write a file first. So it writes a file, which is the teardrop, and then it does run task. Once it runs the written file, which is the payload, then teardrop now runs, and we have another malware independent of the Orion product running, having another communication channel with the adversary. So I'm gonna wrap up the commands quickly and close this session. We have reached its end. So the commands, there are other commands. So we have got idle, exit, set time, collect system description. We have described all of these: kill task, get processed by description, run task, get file system entries, delete files. And then I believe you have got the reboot also, delete registry, set registry, and so on. These are basically the commands. And at the end of this webinar, I highly advise you to check the FireEye technical research paper they have released, and to check the GitHub of FireEye with so many IOCs, hashes, and decoded strings, and so on, okay? And if you have got any questions by now, let me know. Please write them on the chat. I'll be more than happy to answer you before we conclude. And so somebody, I believe, is typing a question right now. Okay. No questions? Okay, guys, then thank you very much. I really appreciate your time, and I look forward to seeing you in a future webinar. Bye-bye, everybody.